Today, we would like to take the opportunity to explore the recycling of a fascinating metal, with its own unique characteristics. Let's take a look at tungsten. Tungsten, designated by the chemical symbol W, is derived from wolfram, the German name for the element. This name originates from its mineral source, wolframite. Tungsten is a remarkable engineering metal, defined by its extreme hardness and high density, but it is equally characterized by its extreme brittleness at room temperature. Tungsten has the highest melting point of any metal, around 3,422 degrees Celsius or 6,192 degrees Fahrenheit, making it crucial for high-temperature applications. Tungsten is an extremely dense metal, with a density of 19.3 grams per cubic centimeter, or 19,250 kilograms per cubic meter, which is comparable to that of gold. It is roughly 1.7 times denser than lead, 2.5 times denser than steel, and over 4 times denser than titanium. Tungsten is roughly 7 times or 700% heavier or more dense than aluminum. Tungsten is generally not soluble in most common acids, such as nitric acid, hydrochloric acid, or sulfuric acid. It is known for its high corrosion resistance and chemical inertness. In an effort to understand some of the key fundamentals that drive the waste and recycling industry, we have developed a website, waste.net, to act as a tool to assist in grasping the 4R strategy of reduce, reuse, recycle, and recover. Within the 4R's recycling sector, we encounter a variety of types and sources of tungsten and tungsten alloy scrap. We will now attempt to outline for you some of the common occurrences of tungsten that are available for recycling. Tungsten carbide, commonly designated with the abbreviation of WC, is an inorganic compound of tungsten and carbon. One of the most commonly encountered forms of tungsten scrap is end-of-life carbide cutting insert tools. Uncoated carbide cutting inserts are typically dull gray in color, but polished surfaces may appear shiny. Common machine shop scrap inserts come in various shapes, including squares, rectangles or triangles. Coated tungsten carbide cutting inserts may commonly contain a titanium nitrate coating, which appears as a golden color, and are commonly found in hexagon, octagon or diamond shapes. Other common scrap tungsten alloys are found in the form of scrap tool steels. T1 tool steel scrap, also known as 1841 alloy, has a chemical composition of 18% tungsten, 4% chromium, 1% vanadium, 0.7% carbon, and the balance iron. Typical items made of T1 steel include drills, taps, reamers and milling cutters. T5 tool steel scraps have a typical composition of 18% tungsten, 4% chromium, 2% vanadium, 0.8% carbon, 8% cobalt, and the balance iron. Common items made of T5 alloys include lathe and planer tools, cut-off tools and forming tools. T15 tool steel scrap has a chemical composition of 12% tungsten, 4% chromium, 5% vanadium, 1.5% carbon, 5% cobalt, and the balance iron. Common items made of T15 steel include blanking dies, broaches, punches and also milling cutters, lathe and planer tools. Large quantities of tungsten scraps are also generated from mining and petrochemical drill bits, end mills, reamers, boring tools and wear parts, such as end-of-life tungsten carbide tri-cones and trenching tools. Tungsten filament scrap includes wires, mesh, coils, blanks, and sinter bar ends, and filaments from incandescent, halogen, and other specialized lighting or bulbs. Tungsten filament scrap also comes from electronic and vacuum tubes, cathodes and filaments in X-ray tubes, electron emission and ion gauge tubes from medical or specialty lab equipment, and industrial equipment, such as arc welding electrodes from TIG welding. Tungsten sludges and residues, such as grinding swarf, tungsten carbide powder, wet or dry filtration scrap, and polishing dust, are processed through chemical methods or hydrometallurgy. This oxidizes and converts the sludges and residues back into raw materials, like ammonium paratungstate, which is commonly referred to as APT. Or it directly reduces the residues into a pure metallic powder form. Rhenium tungsten alloy is a high-performance refractory material, designed to overcome the brittleness of pure tungsten, while maintaining an extremely high melting point and strength. This rhenium tungsten alloy, known as WRE, is extensively used for rocket nozzles, thruster components, jet engine parts, heat shields, and missile components, as it has the ability to withstand high temperatures and pressures. Tungsten and tungsten alloys are blended into ferroalloy compounds. The recovery of tungsten-based ferroalloys, primarily ferrotungsten, that may typically contain 70 to 80% tungsten, are critical additive agents in the metallurgical industry, used to enhance the properties of steel and other alloys. Due to tungsten's extremely high melting point, density, and hardness, these ferroalloy compounds are essential for creating high-strength, durable, and heat-resistant materials. We intend to explore other types of scrap metals, including minor metals and exotic alloys, at some point in the future. Until then, please feel free to reach out to us at your convenience. Waste.net provides a neutral platform to assist in finding a market for scrap, waste and byproducts, with the goal of matching waste material generators directly with beneficial users of those materials. By connecting market participants, we foster collaboration and promote environmental sustainability. Let us assist you in finding potential trading partners for your waste materials. Please feel free to visit us today at www.waste.net.